We can now look at the specific steps in the statistical inference, and for that we first of all specify the problem. And in this case our problem was that we were trying to find out the average consumption expenditure of a particular group, and let's call this X. The next step, we estimate the parameter, and the parameter here would be X bar. One correction, so this should be just consumption expenditure, pardon me, that's a mistake. This is the average. So we start by defining the random variable X as consumption expenditure of a particular group, and in the next step we find the parameter value, which is our X bar, which is basically the average consumption expenditure. Okay, now we also set up the hypothesized value of the parameter. Now this is something which is known to us, known to us, known to us, right? So we set up this parameter value. So let's call this as 1000, and let's say that X bar is 970. Okay, so now we can set up a null hypothesis. Now let's first define what do we mean by null hypothesis. Now null hypothesis is basically a claim. So in this case the claim is, or the claim that we were trying to verify was that the average consumption expenditure of this particular group is 1000, right? And so the null hypothesis is usually specified in terms of, say, some claim. So it can be that the claim was that it's less than 1000, but usually in this case we're taking it as equal to 1000. And likewise we specify the alternate hypothesis, which is that it is not equal to 1000. Okay, and naturally the alternative hypothesis is the one that we come to if we reject the null hypothesis. So that's why the alternative hypothesis is also known as the researcher's hypothesis. In the next step we calculate the test statistic. So now we look at the test statistic, and the broad idea here is this. Just one moment. Yeah. So we know that the posited, that is the hypothesized mean is 1000. अब अगर हमारा जो hypothesized mean 1000 है, पर जो सैंपल से आया है वो है 970. Here 970. So now we want to check if this 970 is statistically different from 1000. Now we know that there are two different numbers, so you'll say yeah it is, but then in terms of distributions, in terms of statistical distributions, are they any different? And the way to do it is by using a test statistic. So we can form a test statistic in this case if let's say that we know the population variance also in this case. So let's say we know the population variance. Then we can specify, say, a Z statistic which looks something like this. This part is standard error of X bar, and it comes from CLT since we are drawing a random sample from the population. So the standard error will be sigma upon root n. Alright. Next, we set a critical value, and critical value, so remember that since we are normalizing it, this Z will follow a normal distribution with mean 0 and variance 1, and we can set up a critical value. So suppose that we set up a critical value at 95% confidence level. So in that case, it will be minus 1.96 plus 1.96. This is the critical area or the rejection area. So if our computed Z statistic exceeds, or rather I would say falls in this red area, we reject null hypothesis. Reject H naught. Which means that statistically the estimated mean from the sample is different from 1000. However, if the computed Z statistic lies between minus 1.96 and plus 1.96, that is somewhere anywhere in this region, then we cannot reject the null hypothesis. And this is a very important note here. So we either reject H naught or we do not reject H naught. We either reject H naught or we do not reject H naught. So, it's a very important point that one needs to understand, that we never try to accept the alternate hypothesis. We either reject H naught or we do not reject H naught. It's similar to saying that in a court of law, either you are guilty or you are not guilty. Okay. And of course, if we do not reject H naught, it doesn't imply we accept alternate hypothesis. And the reason is very clear. Notice that our alternate hypothesis is very vaguely specified. Is very vaguely specified. Now you might come across books which say that we accept alternate hypothesis. Well, that's not technically correct. So it's very important to make this distinction here.